All right, today for 4.7, we are doing absolute value inequalities. So our objectives are to solve absolute value inequalities and to write and solve absolute value inequalities, modeling real life. So some word problems. That's what we're looking at. All right, so remember, because you've talked about absolute values, learned about them for a long time, but remember that absolute value is the distance from the origin. Okay, so in these cases, you'll notice that our variable is inside our absolute value. Okay, so what's the absolute value of x has to be less than 3. So any number whose distance is less than 3 from 0. Okay, so any number less than 3 would be, we could have negative 3, okay, whose distance from 0 is less than 3. Or we could have a positive 3. Okay, anyone whose distance is less than means it's going to be this area in here. Okay, because if we had the absolute value of 2, okay, is that less than 3? Yeah, because the absolute value of 2 is 2. 2 is less than 3. If I had negative 1 for my x, so is the absolute value of negative 1 less than 3? Well, the absolute value of negative 1 is a positive 1. Positive 1 is less than 3. So yes, that one checks out. Okay. So it doesn't matter if they're positive or negative, but they're going to be less than 3. And our x, the variable, is inside the absolute value symbols. That's a little harder to think about. Okay, so in this one, we have the absolute value of x is greater than or equal to 3. So again, or here we have any number whose distance from 0 is greater than or equal to 3. So we would be looking at negative 3. It's greater than or equal to, so it's solid. Any number that's greater. So if we can pick an x value, so let's say we picked negative 4. Is the absolute value of negative 4 greater than or equal to 3? Well, the absolute value of negative 4 is positive 4. So is 4 greater than or equal to 3? Yes, so we're going to draw our arrow this way. Our other one's going to be at the positive 3. It's closed in again because it's greater than or equal to. And we want our x value is a greater. The absolute value of the number, the variable x, is greater than. So it's going to be the stuff that's here to the right. Okay, so when we have an absolute value, we're going to end up with a conjunction and a disjunction. Okay, two different ones. Kind of interesting. Okay, so with that being said, oh, right. Let me erase a little bit of this work. Sorry, it took me a minute to remember here. So let me erase a little bit of this work so we can fill out this information. So this first one is a conjunction, right? If we go back down here, the conjunction is the and statement. There's an intersection there if we look at the set operation. This is also telling us the absolute value inequality symbol is always going to be a less than or a less than or equal to. And that's what we have right here, is a less than. So this is a conjunction. How would we write this conjunction, these conjunctions? Well, we would say x is greater than negative 3, right? And x is less than, because it's going this way, right? X has to be less than a positive 3. Does that make sense? Now we say we'll write that as a combined conjunction. Okay, that's because x is between these two numbers or these two values. So we can write it as a combined conjunction with x in the middle. So we're just taking these and kind of rewriting them. So negative 3 is going to be the smallest one. So negative 3, and our x is greater than, right? Our x is above that. So x is, or negative 3 is, our x is greater than. So if we put our x is greater than. It's the same thing as taking this one and flipping it and writing it as negative 3 is less than x. Okay, just rewriting it the other way. And then this one we already have set up because x is here, x is less than positive 3. That's that combined conjunction. Okay, the absolute value of x is greater than or equal to 3. That's a disjunction. They're not touching, they're not connected. So it's an or statement. So we're just going to write negative, or x is what? Less than or equal to negative 3, or x, okay, and our x's are over here, so x is greater than or equal to a positive 3. Because remember, this is where our x values are, and this is where our x values are. Okay, so our absolute value, if we look at the inequalities, it is going to be super helpful for you to remember that less than or equal to is going to lead to a conjunction, okay, an and statement, and we're going to have an intersection. Whereas if it's greater than or greater than equal to, it leads to a disjunction, an or statement. Okay, so a disjunction is greater than or equal to. Okay, so very helpful stuff to remember there. So let's look at example 1. Use a disjunction or a conjunction to state the solution to each inequality and graph the solution set. All right, so you have this up above. Let's think about it. What was the disjunction? Is it less than or greater than? What about that disjunction? Good. The disjunctions are greater than, which means the conjunctions are less than. So that might be helpful. I'm just going to put that out there to help remind you. So use a disjunction or a conjunction to state the solution to each inequality and graph the solution set. All right, so absolute value of x is greater than 1. Well, that's going to give us a disjunction. Okay, so we know it's going to end up as an or statement. So the number has to be greater than 1. So we're going to go to 1, and it has to be greater than 1. Okay, which means also we could have a negative 1. And how's it going to be greater than 1 there? The distance is greater than 1 if we go this way. All right, and then we have to write that out as a disjunction. So again, our x values are over here. So x is less than, right, negative 1, or x is over here. So x is greater than 1. And this is our or statement. Perfect. B is a less than or equal to, so it's going to be a conjunction. So we're looking for some intersection. So x has to be less than or equal to 4. Okay, so we're going to go at 4, less than or equal to, so it's going to be solid. And x is less than, actually I should have graphed that up here. I try to graph my rough draft up above. So negative 4 has to be less than. Okay, so then for the other one, if we have a negative 4 in there, for our x value, is the absolute value of negative 4 has to be less than, so it would go this way. So we would have some overlap. We would go from negative 4 to positive 4. So this one is a conjunction, and we're going to use a combined conjunction. Our x is between these values. So negative 4 is less than or equal to x, and x has to be less than or equal to a positive 4. Okay, so graphing these, right, graphing like the rough draft and then your final version is how you solve them. And then knowing if it's a conjunction or a disjunction. Okay, so be sure the absolute value is isolated before you write two separate inequalities. Okay, so like in example, this is example 2 and 3, but if you look at the A there, which would be number 2, we have x plus 5 in the absolute value. That is not okay. Okay, so the way that we have to do this is we have to separate it out into 2. Okay, so we're saying, all right, well, the absolute value of x plus 5 has to be less than or equal to 10. The absolute value has to be less than or equal to 10. So that means the absolute value in here could be 10 or it could be negative 10. We don't know. So we're going to set each of those equal. We're going to say, well, x plus 5 could be less than or equal to 10. Or we're going to say x plus 5, okay, could be greater than or equal to negative 10. Now, why did I do that? Or what did I do there? Maybe that's a better question. What did I do? Okay, I flipped the sign here, right? I made it a greater than equal to, as well as making this a negative. So just like when you solve, because this number could be 10 or it could be negative 10, we have to figure that out. Okay, we have to flip the sign to solve that. All right, and then we're ready to solve it. So we would do minus 5 on both sides. X is less than or equal to 5 here. On this one, we would subtract 5. So x is greater than or equal to negative 15 here. All right, so if I was to graph this, let's see, negative 5 to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We won't make it. So we can do 0, 5, 10, 15, and then negative 5, negative 10, negative 15. Okay, so let's see what we got. X is less than or equal to 5. So I'm going to do this, graph these and then find my overall solution. And x is greater than or equal to negative 15. Okay, so my area of overlap, my solution here, is the negative 15 to the positive 5, and my x's are in between there. Okay, so I'm going to write that combined conjunction. Okay, so negative 15 is less than or equal to x is less than or equal to 5. Okay, so let's look at B. Same thing, we've got to watch and make sure we have to isolate the variable, remember? So we're going to take what we have here, since it's not isolated, we have a negative 3 times x plus 6. So we're going to just pull it out of here as 1. Negative 3x plus 6 is greater than 18. And then for the other one, we're going to make it a negative 18. So we have to flip the sign. So negative 3x plus 6 is less than negative 18. Okay, so we flipped the sign again. Okay, flipped the sign from our original, and we made it negative. Just like when you multiply by a negative, you got to flip the sign. All right, so then we would subtract 6. Negative 3x is less than negative 24. Divide by negative 3, which means we have to flip the sign again. X is greater than 8 on this one. And let's do this one. So we subtract 6. Negative 3x is greater than 12. Divide by negative 3. So we flip the sign. X is less than negative 4. All right, so here we have 0, 1, 2, 3, 4, 5, 6, 7, 8. We'll go ahead and put 9. So x is less than negative. Oh, that's negative 4, isn't it? Doggone. Okay, let's try again here. So let me put my 0 here, and we'll do negative 2, negative 4, negative 6, 2, 4, 6, 8, 10. All right, so x is less than negative 4. this way. X is greater than 8 goes this way. All right, so my answer is an or statement, either one of these. So I'm going to graph my final answer and say x is less than -4 or x is greater than 8. Okay, that's my final answer. Okay, it all depends. The conjunction or the disjunction depends on the graph of your solution. So you must graph them. You cannot skip this stage. All right, so absolute value inequalities can be used to describe a range of values. Okay, so example 4. Most human muscle cells function well within 2 degrees of their optimal temperature, 98.6 degrees Fahrenheit. Describe this optimal range of temperature with an absolute value inequality, then solve to find the range. Okay, so this is a lot easier to figure out, I understand, without using an absolute value. I get that, right? Because it's within 2 degrees of the optimal range, which is 98.6. So all you do, and we're going to solve this, it's good to understand the problem and know what answers you're going for, right? So 98.6 degrees, and it's 2 degrees of the optimal temperature, right? So you're just like, okay, well, 98.6 minus 2 is 96.6 degrees, and 98.6 degrees plus 2 is 100.6 degrees. That's fantastic. You know that you have to get an inequality that's going to come out to give you this information. The problem is I'm asking you to apply the skill to do this because common sense won't always help you out. There's going to be more to it. They're going to get more complex. Okay, so I want you to know, it says, remember, I don't know that you've ever been shown this, an absolute value equation. Actually, you have, because when we did equations. So remember, the absolute value equation is the absolute value of x minus the midpoint equals the distance. Okay, this is not in your textbook. Okay, here, the midpoint is your optimal temperature. Okay, this is the optimal temperature. Because think about it, it's the midpoint. This optimal temperature is your midpoint because you have 98.6 and you're going up 2 degrees or you're going down 2 degrees. So it's your midpoint. That's why it makes sense as your midpoint. Now, your distance, okay, is how many degrees you're moving each direction. So the distance that you're going here and here, that's distance. So in order to write this absolute value inequality, the only thing that's going to be different is we're not using an equal sign. So it's going to be the absolute value of x minus 98.6 absolute value. Okay, something, we need an inequality in here, 2. So with this phrase, most human muscle cells function well within 2 degrees of their normal or their optimal temperature. Well within 2 degrees. So is this is that new temperature right here. So is the new temperature going to be greater than, less than, greater than or equal to, less than or equal to 2? Great, it's going to be less than or equal to 2. That is the inequality. Okay, but then it says, then solve to find the range. So this is like part 1 of your answer. Okay, now we need to solve it. So we're going to add 90. Are we going to add 98.6? No, right? We have to isolate our x first. So this is going to call for 2 different inequalities. So we're going to do x minus 98.6 is less than or equal to 2. And then we also have to flip it and say, well, okay, x minus 98.6 could be greater than or equal to -2. All right, so we add 98.6. We get x is less than or equal to 100.6 degrees. All right, which you had here. Cha-ching. And then here, when we add 98.6 degrees to both sides, we're going to get x is greater than or equal to 96.6 degrees, because this was the negative. And again, cha-ching, you had that. You knew that already. But this is a conjunction. Okay, if I graphed these, all right, just like up here, right? Our x, if I go back to this, our x is somewhere in between here and here, so it's a combined conjunction. So our combined conjunction for this would be 96.6 degrees Fahrenheit is less than or equal to x, which is less than or equal to 100.6 degrees Fahrenheit. So again, you just confirmed the math that you knew. You were able to figure out very logically, but it's not always going to be that simple. So we have to practice the skill when it's easier, so we can apply it when it's harder. Okay. And problem 27. So if you don't get to this one, if we don't get finished with that one, it wouldn't be the worst thing, but it would help you on your homework to have it. So problem 27 in your homework. To reduce storage costs, many manufacturers have implemented just-in-time delivery of the components that are assembled for their products. A car company needs parts delivered within 3 minutes of every half hour. Write an absolute value inequality representing the time of delivery. So we want to represent the time of delivery. Then solve the inequality to state the range of acceptable times. So this is what I'm talking about. It gets more complex. So we have to understand it. Okay, so going back to that inequality idea. Okay, the absolute value of x minus your midpoint equals the distance. Okay. So we got to figure out what's the midpoint and what's the distance. Okay, so a car company needs parts delivered within 3 minutes of every half hour. Okay, well, within 3 minutes. So we could have the half hour, right? And we could have plus 3 minutes, or we could have minus 3 minutes. Maybe I should put that minutes. Okay, so that helps me know, like this, the 3 then is your distance. Okay, and we're talking about t or time, so we could use a t if you wanted. You can just leave x if you want. It does not matter to me. So what's your midpoint? It says of every half hour, right? This is half hour. Here's the thing though. This is in minutes, so we should make this in minutes. How many minutes is a half an hour? Good. So 30 minutes. So this is going to be x minus 30 in here. 30 is my midpoint. Okay. Again, let's go back. Car company needs parts delivered within 3 minutes. So more than 3 minutes, less than 3 minutes. Okay, it's going to have to be less than 3 minutes or equal to 3 minutes if it's within 3 minutes. Okay, so here is, you just wrote the inequality. Okay, we got the inequality written. Now we need to solve it. Is the x isolated? No, no it's not. So we're going to have to say x minus 30 is less than or equal to 3. And x minus 30 is, flip the sign, greater than or equal to negative 3. And then you solve. So add 30. So x is less than or equal to 33. Add 30. x is greater than or equal to 27. Again, you could have done this math in your head. You could have figured it out in your head, but you have to be able to show the work. All right, so somewhere in between here, right, we can go 3 minutes less or 3 minutes more. So by looking at this, we know it's the combined conjunction. Okay, between 27 and 33 is when we have to get those, they have to get those deliveries in. So that means 27 is less than or equal to x, which is less than or equal to 33 as your combined conjunction. Sometimes this gets confusing, like this is the same one. All they did is rewrite this one with the number coming first. 27 is less than or equal to x. Okay, so when we're graphing them, we want the x first because it tells us what direction to graph. But when we're writing the combined conjunction, we need the one of them to have the number to come first. And sometimes to know which one, you might have to write both of them to realize, but you always want it to be the less than. Which one's going to be less than? That number needs to come first. All right, there you have it, and you can get started on homework.